So in this video, I am going to discuss case number 4 about partial fractions. So case 4 is when the factors of Q are linear and quadratic and some of the quadratic factors are repeated. So if x squared, if this quadratic factor is an n-fold quadratic factor, then corresponding to this factor, we have the sum of the following n partial fractions. Same sa case 2 for linear factors na denominator will start with the power of n until mag-decrease siya by 1 until the remaining power is 1. For the numerator, same with case 3, constant times x plus constant. Or you can use the modification na instead of x, you will use the derivative of the quadratic factor to replace x. It will depend on you. The result is the same. So, illustration. Evaluate the integral of 2x squared minus x plus 2 all over x raised to 5 plus 2x cubed plus x. So, first is to extract x sa denominator, like this one. And the next is to try to extract this one or break this one into factors. Now, x cubed x raised to 4 plus 2x squared plus 1 is actually equal to x squared plus 1 squared. Okay? X squared plus 1 squared, x raised to 4 plus 2x squared plus 1. So this one can be written as this. And so this quadratic factor x squared plus 1 is being repeated twice with a power of 2. Okay. So we are going to use this one. Partial fractions. Okay. So i-modify na to. Let's modify it by replacing x by the derivative of the quadratic factor. This is our u, x squared plus 1, the derivative is 2x. So x is replaced by 2x. Again, same lang ang result if you will use x instead of 2x. If you will use the original variable na x, same lang. Okay, so let's multiply the whole equation by q of x, and this is the result. Okay. A over x times this, you have x squared plus 1 squared, and then b times 2x plus c over this times this is x lang, and then d times 2x plus e over this times this one. Makancel ang x squared plus 1. So next is to expand. Okay, to expand. So expand x squared plus 1 squared. This is the expansion. And then distribute the constants. Okay. One by one. So a x raised to 4, a times 2x squared, 2ax squared, a times 1, you have a. B times 2x, that's 2bx times x, that's 2bx squared, 2bx squared. And then cx. Okay, for this one, we have d times 2x, that's 2dx times x, 2dx squared times x squared. You have 2d raised to 4. This one, 2d times x raised to 4. And then 2dx times x, 2dx squared times 1. We only have 2dx squared. And then e times x squared, ex cubed. And then e times x times 1, we have ex. So after this, let's compare coefficients. The highest power of x, our right side, is 4. So we'll start with x raised to 4. 0 sa left, we don't have a term containing x raised to 4. So right side, we have a plus 2d. And then next, x cubed, 0 again sa left, e sa right. No? And then x squared, you have 2 sa left. Sa right, we have 2a plus 2b plus 2d. And then for x, we have negative 1 sa left. Sa right, we have c plus e. And then for the constant, you have 2 sa left, a sa right. So with this, you can solve for a, b, c, d, and e. Like a is equal to 2, okay? And then e is equal to 0. So when e is 0, c is equal to negative 1. If a is equal to 2, 2 siya, then d is equal to negative 1. And substitute a equal to 2 and d equal to negative 1, you can solve for b. These are the answers. A equal to 2, b equal to 0. Take note ha. E equal to 0. So if e is 0, c equals negative 1. If a is 2, negative 2 over 2, d is negative 1. So 2 times 2, 4. D is negative 1, negative 2. So 4 minus 2, 2. Transpose 0. So B is equal to 0. Okay, so this is the result. A over x, B times 2x plus C plus D times 2x plus E. And we integrate to integral of dx over x, 0. What remains is negative 1. So it's negative dx over x squared plus 1 squared. And then 0 ang e, negative 2x, so negative 2x dx over x squared plus 1. Okay, let's try to investigate. First term, it's simply ln x. Second term, if you have this one, x squared plus 1, think of inverse function. Or because if you use 1 as x squared plus 1, we don't have x sa numerator. So therefore, use inverse function or trigonometric functions. Depende sa imo. For the third term, it's simply change a variable. U, x squared plus 1 du is 2x dx. 2x dx. Okay, so second term, let's use trigonometric substitution. Since plus siya, then we'll use tangent. Di ba? U equal to A tangent theta. Our U is simply X. Our A is 1 man. So X is equal to 1 tangent theta. And we have dx equal to secant squared d theta. Next step, this one, U equal to x squared plus 1 du is 2x dx. And so we have 2 times integral of, dx over x, or simply ln x, minus our dx is secant squared theta d theta, and our denominator x squared plus 1. Our x is tangent theta, it's tangent squared theta plus 1, quantity squared minus du, 2x dx, 2x dx du over u. So for the first and third term, settled na. 2 ln x, and third term is negative ln of u. Now, for the second term, we replace tangent squared theta plus 1 by secant squared theta. It's an identity. And so, makancel ang secant squared theta. Makancel. So, what remains second term is secant squared theta squared man. Secant squared theta. Now, we don't have an integral of 1 over secant squared theta. So, we're going to use reciprocal function. The reciprocal of secant is cosine. So, the second term becomes integral of cosine squared theta. And with this, we're going to use the integral of powers of cosine. Sine and cosine. In this case, the exponent is even. So we are going to use the identity for double angle identity. Okay. So, morning identity. Cosine squared theta is equal to 1 plus cosine 2 theta over 2 d theta. So let's separate the two terms. Second term, this one, negative 1/2 d theta minus 1/2 integral of cosine 2 theta d theta. And u 2 theta du 2 d theta. Integral of d theta, theta lang. And then cosine u d theta is du over 2. So this number 2 will be multiplied sa 1/2. It becomes 1/4. Integral of cosine u is sine u. And with u equal to 2 theta, so it's sine of 2 theta. And then next na step is to replace theta in terms of x. Okay. But we don't have the sine 2 theta, so we will replace this one by its identity. Sine 2 theta is 2 sine theta cosine theta. So, and makansalan 2 og 4. 2 lang bilin. Okay. So next is, this is our substitution. X equal to tangent theta. So from this triangle, tangent theta is x over 1. Right? X over 1. And the hypotenuse is square root of x squared plus 1. So to solve for sine theta is x over square root of x squared plus 1, while ang cosine theta is 1 over square root of x squared plus 1. So we are going to substitute this one there is a second in a term. While sa theta, we can replace it by arctan of x. Theta, arctan of x. Okay, so we have this minus 2 ln x. Theta is arctan of x. And then this is sine. And then cosine. So to simplify, the radical sign is removed. Okay, ma-square man eh. And then pwede ma-combine. So the final answer is this. 2 ln x minus 1/2 arctan of x minus x to ma-remove ang radical sign. You have x squared plus 1 minus ln of x squared plus 1 plus c. So, for case 4, focus on the quadratic factor. Since it is repeated, then continue to have the numerators constant, x plus constant, or you can replace x by the derivative of the denominator. So continue to add fractions until the power becomes 1. The power of the quadratic factor or linear factor becomes 1. Okay, so I hope that you have learned from this one. Thank you for watching.